Hello again, everyone. So for today's video, we will be learning about the physical and chemical properties of lipids. Lipid is a term that is given to a diverse group of macromolecules that are grouped together because of their evident insolubility in water and polar solvents. For today's experiment, we will be utilizing the two commonly encountered lipids, your triacylglycerol in the form of oil, and of course your cholesterol. Let us begin by determining the miscibility and solubility of oil and cholesterol in different solvents. Miscibility is used to describe the formation of solution between a liquid solute and a liquid solvent, while solubility is between a solid solute and a liquid solvent. The solvent that we will be using is water, ethanol, ether, and chloroform. To do this, add drops of coconut oil in different test tubes labeled with the name of the solvents that will be used to test its miscibility. Then add the different solvents that correspond to the label in the test tube. After the addition, shake the test tubes carefully and observe for layer formation. A layer means an oil is immiscible in that solvent. The result is very clear. Oil is immiscible in polar solvents such as water as a layer is observed, so as in ethanol. It is however miscible in nonpolar solvents such as your ether, because as you observe, there is no formation of a layer. And it was also miscible in chloroform. The same procedure is conducted to test the solubility of cholesterol crystals. Cholesterol crystal is added to 4 different test tubes labeled with the name of the solvent that will be used to test its solubility. Then, solvents corresponding to the label were then added to the test tubes. This time, we will be looking for remaining solids instead of a layer. If there are remaining solids, then it means that cholesterol is insoluble in that solvent. The result is very similar to that of oil. Cholesterol was insoluble in water, and it was also insoluble in ethanol. It was, however, soluble in chloroform and in ether. As you could see, there were no solids remaining. So we learned that oils are immiscible in water and polar solvents, while they are miscible in non-polar solvents. In the same manner, cholesterol is insoluble in water and polar solvents, and it is soluble in non-polar solvents. The next procedure is a spot test. This is the simplest test for the presence of fats and oils. This is based on the fact that fats and oils leave a translucent spot on papers. This is a common scenario that we usually encounter every day, especially when we buy oily foods wrapped in paper bags. We will be subjecting coconut oil, glycerol, ether, and ethanol for spot test. To do this, simply add a drop of each substance to the portion of the paper labeled with its name. And then, wait for a few minutes until all liquids dry up. The formation of a translucent spot is best observed against a white light. As you could see, only coconut oil was able to produce a permanent translucent spot. This means that among all the samples tested, only coconut oil is non-volatile. Now, we will do the acrolein test. It is used to determine the presence of glycerol, and since your triacylglycerol contains a glycerol backbone, therefore this can also be used to determine its presence. We will be subjecting coconut oil to acrolein test. At the same time, glycerol is also tested as a standard. To do this, add 10 drops of coconut oil and glycerol to 2 separate test tubes. And then, add a pinch of potassium bisulfate into each of the test tubes. And then, heat the mixtures in the test tubes gently over a Bunsen burner flame. Observe for the formation of a black precipitate which has a characteristic odor of a burnt fat. Both coconut oil and glycerol were able to produce a black precipitate with a burnt fat odor, which means to say that our coconut oil also contains glycerol. The next test is the iodine number. This is a test for unsaturation. As we know, Oils may contain unsaturated fatty acids which contains carbon-to-carbon double bond in its structure. These double bonds can undergo addition reaction with iodine, which results in a decolorization of iodine solution. The higher the degree of decolorization, the more unsaturated the oil is. To show differences in unsaturation in different oil samples, we will be using coconut oil, olive oil, and cottonseed oil. Add 1 ml of the oil samples into 3 separate test tubes. To each test tube, add 3 drops of iodine solution. Shake the test tubes after each addition, and then observe for the disappearance of the color of the iodine solution. The result indicated that olive oil and cottonseed oil have a higher degree of unsaturation than coconut oil. As you see in the result, the color of iodine disappeared faster in olive oil and cottonseed oil, which means to say that they contain more double bonds. The next test is to test whether an oil is rancid or not. Rancidity is the development of an unpleasant smell in fats and oils. When an oil becomes rancid, free fatty acids are liberated, making the oil acidic. The easiest way to test if an oil is rancid is to test its acidity through litmus paper. So simply add drops of fresh and rancid oil into blue and red litmus papers respectively and observe for changes in color. Fresh coconut oil resulted no color change in the red and blue litmus paper. In the case of rancid oil, it converted blue litmus paper to red, which means to say that it's already acidic. The last 2 tests for this experiment are used to test for cholesterol. The first test is the Salkowski's test, which is a qualitative test for cholesterol. To do this, add a small amount of cholesterol in the test tube, and then dissolve the cholesterol in chloroform. After that, add 2 drops of concentrated sulfuric acid into the solution. Upon addition, a cherry red coloration was then observed, which indicates a positive result for the presence of cholesterol. The final test is the Lieberman-Borchardt test. This can be used for quantitative determination of cholesterol. We begin this test by dissolving a small amount of cholesterol crystal in 1 ml of chloroform. And then add half an ml of acetic anhydride to the solution. Finally, add 2 drops of concentrated sulfuric acid. The solution will begin to darken until eventually it will be converted into an emerald green solution. Emerald green solution is a positive result for this test. So in this video, I have just shown you some physical and chemical properties of some commonly encountered lipids. May these help you in answering your worksheet.